Damn. Wonder how hard that guy sit at that table. What's good? I'm Terrence, and I'm gonna make a seismometer detect when I hit my desk and plot it on the Richter scale. Bro, why am I doing this? The way you get a Richter scale reading is, first, you buy a 4-figure seismometer. Then you wait for an earthquake. The seismometer will take a reading and it'll look something like this. Then you find out how big the peak amplitude is and then measure how far the epicenter of the earthquake is from the seismometer. And after all that, you plug in this scary formula and what the heck? Isami torrents from the internet. Your bill will be $2,500. Tip options are 20, 30, and 40%. Very, very reasonable. Brother, how did you get in my house? We aren't doing that. Instead, we're gonna do this. Ladies and gentlemen, I'd like to introduce our 3 modules. The first one, coming in at $3, 8 pins, fighting out of Amazon.com via some Temu factory. We have the accelerometer. He may be a little small, but Mr. Rometer will get the acceleration data and send it over to our second module, coming in at $6 and 1, 2, I don't even know how many pins. We have the microcontroller. He will take the raw acceleration data, parse it, and calculate the Richter scale reading. But we're missing one important piece. Drum roll, please. The LED array, which will display the data we get into the physical world. Okay, now we got all that, we can start building. Dang. Alright, as you can see from this Amazon page, our accelerometers do not come with pins. So we gotta solder! So soldering is melting solder, which is a combination of tin and lead to create permanent electrical connections between these pins and the circuit board on the accelerometer. So we can plug this accelerometer into a breadboard. Okay, now that we got everything plugged in, we need to write some firmware to get the microcontroller and the accelerometer talking. Please. Yo, I'm so dumb, bro. Okay, so we got this John working. So if we look over here, we get the sensor data. It's not moving, so it's pretty much 0 for all of these. And once we start moving it, we got it working. The way it works is the Arduino sends the address of this microcontroller to the microcontroller, and the microcontroller's like, oh my goodness, it's me. So then, yeah, bro, nobody cares. Now that we have the accelerometer communicating with Arduino, we need to write some code to map the acceleration values to this chart for the earthquake scale. So I just went ahead and did it. As you can see, we got the peak acceleration value as well as the Mercalli scale. I'm slamming these earthquakes right now on my desk. Okay, now that we got that covered, we just need to make the LED display. So I'm doing this quickly in Onshape, just drilling some holes, making some holes, blah, blah, blah. Yeah, so we got a slight problem. So as you can see, there are no holes because I made them too small in the software. So the 3D printer tried, you can see the little circles, but it didn't work. So that's all good because we made another one with adequately sized holes and it's black. So it looks a little nicer in my opinion. Guess how we're connecting this to this? That's right, we're soldering. Okay, so the plan is to take the LED inside the array and we're gonna solder this wire onto the wire of the LED. The slight issue with that is I only got 2 hands. So I need to hold this wire, hold the solder here, hold the soldering gun to heat it up. That's not doable. So the solution is okay, just came, let's make it. And boom. All right, next step is to cut out some wires. All right, next step is to strip the wires so we get the little metal part sticking out so we can actually use it. The footage I took was trash.
Oh my God, bro. Oh, hell no, man.
But we got it all done, so it worked out. Okay, now we get to the actual fun part of soldering the wires onto the LEDs. Okay, so sometimes you realize a bad idea is bad too far deep, and it looks like a freaking spider, bro. Oh no. Okay. Electronically it'll still work though, so that's fine. Anyway, if you thought I was gonna redo it, yeah, I wasn't. So we just finished making it. Here it is. Everything's all plugged in, and it works. Yep. Okay, last thing for this project, I wrote a script to where if this detects a magnitude 7 or above earthquake, it'll restart my computer. Yeah, I don't know why I did that, but here we are.
What could go wrong? We're gonna try to beat one of the hardest levels in Celeste. If you guys know Summit Seaside, without restarting my computer with this Crash Out Detector.
When I said this, I thought it would just be around 10 minutes for this level and I can get the clip done easy. And for a little bit, I was vindicated. The first 2 levels were an absolute breeze.
Okay.
I flew through in a total of only 5 deaths in 3 minutes.
There you go. Okay.
So where did the other 35 minutes come from? This last hellish, horrible level. Yeah. Look at how freaking long it is. Oh. Why is it so long? I died on this level 189 times. I was getting cooked.
Bro.
But now, struggling, constantly failing. Did I handle it successfully? Did I control myself, not crashing out? Improving my invention futile? Well, I simply moved the crash out somewhere else. But I got up out of that bed, walked over to my desk, and finished the job.
Bro, what the?
A few minutes later, and
Oh! Yeah, I low-key hate this thing, but it was a super fun project to make, and I'm planning on making more projects and doing more videos. So if y'all got any ideas, I'd be more than happy to take a look. Thank you guys so much for watching. See you guys later.